So before I start solving problems, I need to explain to you what is natural numbers, whole numbers, because that's all it's going to be about types of numbers and sets. So first of all, natural numbers are the numbers that include the whole numbers besides of zero. Okay, those are all natural numbers. Next, whole numbers. Whole numbers are the all whole numbers, and you include here zero also. That's the difference between natural numbers and whole numbers. Next is coming integers. So you know what? Let me write down here just like that also. Whole number, it will be represented as 0, 1, 2, 3, and 3 dots. This color doesn't look good. I'll tell you what, let me make it more, a little bit thicker, huh? Yeah, much better. Now here, this one, integers, those are all the positive and negative numbers, including zeros. Okay, rational numbers are all numbers you can represent in the format of fraction. The form of the rational numbers are this is in the format of fractions. As long as you can represent in the form of fraction, then it's a rational number. For example, if you take 3, you can represent as a 3 over 1. That's mean it's rational. You can represent a rational can be also decimal notation. It can be decimal notation if you represent in the format of basic fractions. Here it is. 6.57 equals 6 and 57 over 100. Or 3.33, see this line on the top, that's mean 3.33333. So you can represent in the format of fraction either 3.33 over 100 or 3.333 over 1000, 333 over 1000, and so on. Irrational numbers are the numbers that include, let's say, logarithm, letter E, that's very well known in math, pi, and let's say square root. Those are irrational numbers. Or the pi, it's equal 3.147. It's considered irrational numbers. Real numbers are everything. It includes all numbers, everything. Rational plus irrational. Here it is. Real numbers are rational plus irrational. Okay? All right. Said that, we can start working. All right. Okay, question number 1. We have negative 9. So negative 9 is integer, right? If you look at the table we built here, because it's negative, integer, I would recommend you to write down here, okay? It's integer, it's rational, because you can represent negative 9 over 1, right? It's irrational, it's not irrational, so I'm putting also real, yes. So everything else, if it will ask you, that's mean its answer gonna be no, because these all threes are yes. Number 2. What do we have? Question number 2. Next is, let's try pi. What is pi? Is it integer? No. Is it rational number? No. Is it irrational number? Yes. Why is it not integer? Because it's not a whole number. Why is it not a rational number? Because it's not it's not a fraction. It's pi is the number that is accepted in math. Numbers that letter that's accepted in math. Pi is 3.147. So and it is, yes, irrational, and yes, it is real. Next, negative 0.333. Actually, I took that example. Is it integer? No. Is it rational? Because not integer, because it's not a whole number. Is it rational? Yes, it is rational. Is it irrational? No, because it's not a ladder, it's not a log, it's not a square root, so it's not irrational. So let me clean it. And what else? It is real. Everything is going to be real, guys. Next one. Negative 4.888. Is it integer? No, of course not. It has fraction. Is it rational? Yes, it is rational. Is it irrational? No. Is it real? Yes, real. You can look, it's a similar. Third and fourth question. Next. Radical degree 5 from 3. Let's see, is it integer? No, it's not integer because not a whole number, it's square root. Is it, cubic radical, radical of degree 5. Is it rational? No, it's not a rational because you can't represent as a fraction. It has this radical that already keeps it as irrational. It's irrational. And obviously it's real. Question number 6. It's let's see, 0. Is it irrational? No, it's a real number. It's a whole number. Let me write down whole number. It's a rational number because you can represent 0 over 1, right? It is integer. It is real number, obviously. Next one, let's see, negative 14, for example. So obviously it's gonna be, it's an integer, right? Because it's a whole number, but negative. It's rational because you can represent negative 14 over 1. Is it irrational? No, it is a real number also. Next, number 8, 7 over 8. So is it's rational? Yes. It's not a whole number. It's not irrational number because it doesn't have log or pi or e or square root or radical. It is not natural number because it's not whole number. And real numbers. That's all. Number 9, negative square root 2, example 9, negative square root 2. Now this one is definitely irrational. Is it anything else? Can be integer, natural number, rational, whole number? No, answer is no. The only thing left, real number. Next, example 10. So let's say we need write a set by using element, and we need to write down in the form of the set format the numbers that is even, integer, even and greater than 8. Even and greater than 8. So we are going to write down in the format of set. So greater than 8 is going to be an even. I would put greater than 8, we'll start 9, 10, 11, 12. But because it says even, then after 8 it's going to be 10, 12, 14, and so on. Okay? Keywords here, even and greater than 8. Therefore, 8 is not going to be included because greater than 8. Okay, next one. In the roster notation, we want to write down the word plus. So word plus, we want to write down in the roster notation same way, which is going to be P, L, comma, U, comma, S, comma, spell it through comma. Okay? Next, write the set in the roster form, which is going to be set of integers greater than 5. Okay, greater than 5 and set of integers. Set of integers meaning it's going to be whole numbers, right? So greater than 5, there is no other condition. Greater than 5, it starts with 6, 7, 8, and then 3 commas. Okay. Question number 13. So now we need to write down the set in the builder notation. Set builder notation. So we are given G is, or the even number start from 4 to 10, which is going to be 4, 6, 8, 10. This is what is given. Okay? We need to put in the set builder notation. This is how it's going to look like. So our x is integer, right? Because whole numbers we have there. So x is represented as an integer. We put here x, that means we are talking about x, and separating with vertical line, and put information is an integer. And what we can say, it's this x is between 4 and 10, right? And 4, and x is even, integer, even. Let me put this way, might as well. If I put even, that already means it's integer, is even. And our x is greater equal 4, less equal 10, yes? But because, how we mention it that it's are even, because we have here even, then starting from 4, we are going to go take only even numbers, 4, 6, 8, and 10. Okay. And I'll solve one more. Write the set in set builder notation. So we have, in this set, we have names of, let's say, names of planets. Mars, Jupiter, what else? Saturn, and Neptune. To write down in the set builder notation, we are going to put this way. So P, this is the answer, P is equal, we are replacing as an X because this X can be Mars, Jupiter, Saturn, Uranus, Neptune. And X is, explaining what is X, is a planet. Okay. And X is farther from the sun than Earth. This is how we put it there. So trying to explain. So when we say is a planet, right? That we give you explanation that it's going to be planet, and it's farther than from sun than Earth. So this way it's going to be clear that it's going to be Mars, Jupiter, Saturn, Uranus, Neptune. That's how we explain. Okay. I will move to record the next video. Okie dokie. Thanks for watching.